So yes, we have finished what? We have finished the digital electronics part. So today we are going to start with what? We are going to start with a new subject, control system. So for HAL, there will be very basic things that will be asked. Okay, very basic question. No such questions will be asked which will take you more than 1 minute to solve. So mostly theoretical questions will be asked. Along with that, few numericals which are very easy to solve. Okay, so then let us begin with control system. So first let me tell you what is control system. Okay, so what do we mean by a system and what do we mean by a control system? So system is basically what? It is a physical component which gives proper output, or basically what? It is actually interconnection of components that give you a output. Okay, interconnection of component that gives you output. Now a simple example of your this system is what? Suppose if you are in a room. Okay, in a room. So in your room, the room temperature, it can vary from like 26 degree. Okay, it can vary from like your 26 degree to 37 degree on a normal summer day. Okay, so here you can see this is your room temperature in degree C, and this is what? This is your hour or time. Okay, just wait a minute.
Yes.
So is there two voices coming?
No, sir. Only your voice is coming. Yeah.
Okay, then why am I able to hear two voices? I don't know. So it's okay. Yeah. So I was telling what? This is the room temperature and this is the time. So your room temperature can vary from 26 degree to 37 degree on a normal summer day. So this is what? This is basically a system. So your system temperature, it may vary depending on various factor. Like if your room, it is east facing, it is said that in east facing room the temperature is usually little bit higher in your summer days. Okay, because your sunlight it falls for the maximum amount of day. Or if your room it doesn't has windows, proper ventilation, so your room temperature might go up even more than 37 degrees. So this is what? This is a basically a system. Okay, system. Now if you want to control this system, so here our output was basically the room temperature. So what do we mean by control system? If you want to control the output of a system, that becomes your control system. Like in your room, if you install one AC and you keep the AC set on 25 degrees C. So now whatever is your outside room temperature, your inside your room, always this temperature will be maintained, or it will be near this temperature that your air conditioner will constantly maintain. Okay, so such kind of system where we have basically a controlled output, that is known as what? That is known as your control system. Okay, that is known as your control system. So now let us see how many types of. Hello, you want to say something?
Yes, sir.
Yes, tell me what.
No, sir. It's clear, sir.
Okay, fine. So what are the different kind of classification of control system? So control system can be basically classified into open loop and closed loop. So I am talking about only classical control system over here. Okay, no non-linear control, distributed control, nothing, all those things, only about your classical control system. So classical control system means what? The control system that depends on transfer function for the analysis of system. Okay, we depend totally on transfer function for our analysis. That is known as what? Classical control system. So in our gate syllabus or in any PSU, we just have to study about classical control. So in classical control system, basically we can classify it in two parts. They are what? Open loop control system and closed loop control system. Now in closed loop control system, we have two more sub classification. So one of them is positive feedback, another is negative feedback. So let us see what is your open loop control system. So this is basically the block diagram of your open loop control system. Okay, so this is your block diagram of open loop control system. So in open loop control system, basically there is no relationship between input and output, and always there is your human interference for your particular input to get your desired output. For example, like your ceiling fan. So ceiling fan is an example of your open loop system. So you have this regulator. Okay, so there are this demarcation line is present. So you have 0, 1, 2, 3, 4, 5. So if you switch this knob to 1, so your fan will rotate at your minimum RPM, and if you rotate this knob to 5, your fan will rotate at your maximum RPM. So according to your need, okay, if it is winter, you will keep the fan at 1. If it is a summer day, you will keep it on 5. So according to your need, you are basically doing what? You are basically changing the position of the knob to get the desired revolutions per minute of your ceiling fan. So this is basically what? This is your open loop system. So here this controller is basically what? Controller is your component that basically controls the process. Okay, it controls the process. So here our controller is this regulator, and process is processor or process. What it is? It is your fan. Why? Because this fan is giving you the output. Okay, so this is about your open loop system. Now what do we mean by closed loop system? So if you go back to your flow chart, okay, so there I have already shown you that closed loop system, it can be classified in your positive feedback and as well as your negative feedback. So now what do we mean by a closed loop system? So a closed loop system is basically a system in which there is a relationship between input and output. Okay, there is a relationship between input and output, and once you have actually selected this input, this is sometimes also known as set point. Okay, set point, or also known as desired output. So whichever terminology you want to say, either you can say it as input, you can say it as set point, or you can even say it as desired output. So once you have said this, what will happen? Your controller, it will automatically bring the output to your actual output, or it will means this actual output will become near about to desired output. So this is what is we mean by your closed loop control system, that in closed loop control system we always take a feedback signal with the help of this sensor, or we always actually monitor this output with the help of this sensor and compare the output of this sensor with your desired output, so as to keep the deviation in the actual output and desired output minimum in a closed loop control system or a negative feedback system. Okay, so in a negative feedback system, basically we try to minimize this error. So always this is your comparator. Okay, this is comparator. This is where your desired output is actually compared with the actual output, and then according to this error your controller takes action and it rectifies the process to get your desired output. Okay, so basically what this is your, if over here this output is subtracted from this input, okay, so then this is your negative feedback, and if in case these two are added, so you will say what? That this is your positive feedback system. Okay, positive feedback system. See, usually the normal air conditioner, okay, normal air conditioner that we have, okay, the means the previous generation of air conditioners that we used to have, those were open loop system. Okay, open loop system. I won't be going into that much depth. So you might feel that it is what? It is your const means you might feel that it is your closed loop system. The previous window model AC. Okay, those were, you might feel that those were closed loop system, because once you set the temperature using remote at 25 degree, it is constantly maintained at 25 degree. But what happens if more number of people enter the room, or if sometimes outside temperature it increases, so your AC cannot take proper actions. So that is why those systems were what? Those were your open loop system. But now the recent ACs that you see, smart ACs, smart air conditioner, so there what we have basically, if you have seen, so if you set over here 25 degree C, okay, 25 degree C, so basically there are lot of sensors in your AC these days. Suppose this is your process. Process means what? Your room temperature or your room. Only you are present. So this AC, the smart AC, it will consume minimum amount of energy to maintain this 25 degree C. Okay, you can understand it like this. Suppose your actual output, when you initially switch on the AC, your room temperature is somewhere 32 degrees C. So slowly what happens, your desired output, okay, means sorry, your actual output, it starts to get near your desired output. So this error will be like, error will be desired output 25 degree C minus 32 degree C. So that is what? Minus 7 degree. So that means this AC is constantly getting a negative error signal, negative error signal. So it will consume energy and it will start to cool your room. Now slowly this 20 means 25 degree is fixed. This temperature will keep on coming. Okay, it will keep on coming down. So at one point this will be 25.01, or this much preciseness will not be there. Suppose it comes down to 24.5. So you can see this is plus 0.5 degree. So immediately as your error signal is becoming positive, so this controller means what? Your air conditioner, it will get this signal that we need to stop consuming energy, we need to stop the AC, your room temperature has been achieved. Only thing that will be on, it will be your fan of the air conditioner. So this is when only you are present. Now suppose if your friends also come into your room and you haven't actually changed the temperature. So what will happen? Now basically there are like 3-4 people in your room. So more amount of people are present. So what will happen? This AC, it requires more energy to consume, means more energy it will consume to maintain this temperature. Or suppose what happens, you people are sitting and suddenly your means what happens, the room temperature, outside room temperature, it starts to increase. So this air conditioner on its own, it will start to maintain the temperature of the room near to 25 degrees C. Okay, near to 25 degrees C. So now you understood, Surjit, what is this desired output and actual output, and why this input is termed as desired output. Is this clear now?
Yes, yes.
Okay. So Shriyari, you need to watch the recording for like 10 minutes, okay? So we have started only 10 minutes ago because I was teaching using mute. I haven't unmuted myself, okay? So
Oh
only
my
10
God.
minutes you have to see. So you haven't missed that much. So now is what we have your representation of closed loop system. Okay, representation of closed loop system.
Hello, Rahul sir. I am having some power issues, so I will get back later.
Arey yaar. So once again I have muted, since I don't know how this happened. From when has this happened? Huh? Pardon, I can't hear you. Means I don't know how this happens. Means your voice is constantly breaking, Surjit. Means I don't know how this happens, okay? Constantly this gets muted. So whenever this happens, you should tell me immediately by unmuting yourself. From which point have I muted myself? Your voice is breaking, Surjit. I cannot hear you. Okay, it's okay. Chalo. Whatever has been. No, you are not audible. Means your voice is constantly breaking. So at what point have I means muted myself? Tell me. From there I will explain once again. Okay, I will explain this once again. I will explain this once again. So 1850 was the last time. So 2 minutes ago, I might have done. So look over here. This is what representation of closed loop. So it's okay, Surjit. You can mute yourself. So you can write in the chat box. Okay, no need for speaking because your voice is breaking. So you can just type in the chat box. Okay, type in the chat box. So look over here. So this is what? This is your representation of closed loop. So this input is what? This input is the Laplace transform. Laplace transform of input, this RS. This CS is what? Laplace transform of output. This is basically your adder. Okay, adder. So we have what is the difference between this RS and CS. So that difference is written over here, that is denoted by E of S. As I told you, this is error, sometimes also known as difference signal. This signal, this is known as feedback signal, which is actually the product of CS and HS. Just now we are going to see. So this is known as feedback signal. Okay. So now I am trying to derive the relationship between CS and RS. Okay. What is the relationship between this CS and RS that I am trying to get over here? So ES is equal to what? You can see that ES is equal to RS is being added, and this VF is plus minus. Okay. And we can see over here that if you take this feedback path, so if this is your feedback path, so if this is HS, so input is what? Input is C of S. So this is your input. And what is the output? Output is this feedback signal. So V of S is equal to H of S into CS. Okay, H of S into CS. So this is E of S. Now, simply what you can do, you can substitute E of S as CS by GS. So substitute that over here. CS by GS is equal to RS plus minus HS into CS. Okay. So now what we can do, we can take this over here. So CS is equal to GS into RS plus minus HS into CS into GS. So now let us bring this over here. So CS common 1. See, it was previously plus minus. Plus for feedback, positive feedback, and minus for negative feedback. Now this becomes minus plus GS dot HS is equal to GS into RS. So now CS by RS is equal to GS divided by 1 minus G of S H of S for your positive feedback, and it becomes G of S 1 plus GSHS for your negative feedback. So this we have seen from our means whenever we have studied the transfer function, closed loop transfer function, also known as CLTF of your closed loop system. So if it is your positive feedback, your CLTF, it will look like this. If it is your negative feedback, your CLTF will look like this. Okay, so we have studied this from our BTech in our GATE exam also, and now for HL also we have seen. Okay, so this is the transfer function. Now let us understand what is the difference between positive feedback and negative feedback. So negative feedback is what? The transfer function, closed loop transfer function, this is your negative feedback, and for your positive feedback, TS is equal to CS by RS, which is equal to GS 1 minus GS HS. Okay, so this is your positive feedback. So okay, one thing that might be asked to you is, where is positive feedback used and where is negative feedback used? So positive feedback is used in oscillator and multivibrators. Okay, we use positive feedback in your oscillators and multivibrators, whereas your negative feedback, it is used where? Negative feedback is used in your amplifiers. Okay, it is used where? It is used in your amplifiers. Now next is what? Next is positive feedback. See, I cannot prove all the things because if I start proving, then it will take lot of time. So positive feedback basically decreases the stability, whereas negative feedback increases the stability. So this point we are going to see later on. Okay, this point we are going to see later on. Now this is very important. Sometimes positive feedback circuit is also known as regenerative circuit. Okay, this is known as regenerative, and your negative feedback is known as what? It is known as your degenerative circuit. Okay, your negative feedback circuit is also known as what? It is known as degenerative circuit. Why? Because you can see over here that error is what? Error is CS minus RS. That means, sorry, RS minus CS. So that means basically here you are trying to do what? You are trying to minimize the error. Okay, minimize the error. Why? Because I told you, if you go back and see, RS is your what? It is your desired output, and CS is what? Actual. So your main aim is what? That your actual output becomes same as your or equivalent to desired output. So basically your main aim is to what? Your main aim is to minimize the error or basically subtract the error. But in regenerate means in your positive feedback, your ES is what? ES is equal to RS plus CS. Okay. So here basically you are trying to maximize the error. Okay. Or you are trying to regenerate the error. Okay. You are trying to regenerate the error. Surjit, give me just 1 minute. Hello, Surjit. So give me just 1 minute. Okay. I will be back in like 1 minute. Yeah. Yes. So we were talking about what? We were talking about the difference between positive feedback and negative feedback. So I told you what? That a positive feedback is known as your regenerative circuit, and your negative feedback, it is known as what? It is known as your degenerative circuit. Okay. So one thing, if there is no mentioning of positive feedback or any kind of feedback in a closed loop system, by default you will consider negative feedback system. So if there is no mention in a closed loop system, nothing has been mentioned that whether it is positive or negative feedback, by default you need to consider it as your negative feedback system. If it is a positive feedback system, so it will be mentioned in your question properly that a closed loop system is positive feedback. Never assume positive feedback on your own. Okay. So now there is one special case that we have. Okay, special case in this negative feedback. Okay, so I will draw it over here only. So if this Hs equal to 1, okay, previously our transfer function was, it was Gs divided by 1 plus GHs. Now if Hs becomes 1, then your transfer function becomes Gs divided by 1 plus Gs, and this is known as what? This is known as your negative unity feedback system. Negative unity feedback system. Okay. So in negative unity feedback system, this Hs is actually what? Hs becomes yours a sensor that is measuring your actual output and comparing it with the desired output. So basically it is simply just measuring the actual output. That's it. There is no other process involved in measuring and conversion. Okay. So directly we are measuring and we are feeding it. Or you can even say this only happens. See, so I will tell you, ES is what? RS minus CS, or over here, sorry, means this was VFS. Sometimes this is asked in your interview. So RS VFS you can write, we have already seen what to write of VFS. It is CS into HS. So now if your RS and CS, they have the same units, okay, if they have the same units, then we can subtract two quantities. Like you can always subtract two numbers. Okay, you can subtract and add two numbers. So you can write this as 100 minus of minus 5. You can write it like this. So you can always subtract two numbers. But what if I give you 100 minus a, okay, or 100 minus car? You cannot do that. Comparison always happens between two similar quantity or two similar product. You cannot compare one two-wheeler with a four-wheeler. Okay, you cannot compare a two-wheeler with a four-wheeler, or you cannot compare a human with a dog. You cannot do that. Whenever you are making a comparison, you are doing it with a similar quantity. So same is over here. If your output and input, they are of same unit, then what happens? Then this HS becomes 1. Then you can write RS minus CS. But if suppose here you have like displacement or position, so that is in meter, and here you have what? You are having velocity in your output. Okay, so you can never subtract position with velocity. So then what you need to have over here? You need to have a differentiator over here, so that this velocity, when it is differentiated, you get a unit of displacement or position. So did you understand why this HS is important? So HS becomes 1 whenever this output and input, they are of same quantity. Is this clear? Any doubts? So this sometimes are asked in your interview. So I have cleared it. Any doubt, Surjit?
Clear, sir.
Any doubt? Okay, fine. So next is what? Next we have open loop transfer function of a closed loop system. Okay. So we have seen what? The closed loop transfer function is CS. Sorry if there was HS also present over here. So it was what? 1 plus G of S, H of S. Okay. So this was your closed loop transfer function. Now if this for closed loop transfer function, if I ask you open loop transfer function, then what are you going to say? What are you going to say me? So open loop transfer function will be what? Open loop transfer function over here.
So GHHS.
Yes, very good. So we are never going to open this system from here. Okay, we are never going to open it from here. We always open the system from this feedback point. Okay, we are going to open it from feedback point, and open loop transfer function will be given by GSHS. So always remember that if for a closed loop system, if your OLTF is asked, so you are going to write what? You are going to write GSHS. Okay. Now, how is your open loop transfer function related with your CLTF? So if you want to write for a negative, see, for a negative unity feedback, whatever is the relation I am telling. See, if this is negative unity feedback, TS will be what? It will be GS divided by 1 plus GS. As for negative unity feedback, H is equal to 1. So OLTF will be what? OLTF will be GS, and this TS is what? It is CLTF. So CLTF is equal to OLTF. Okay, if you write it from this two equation. So this is very simple. I have just explained it. I know you people know this, but still, okay. Now suppose if I have a negative unity feedback closed loop transfer function, this, how can we find the OLTF? So this is your closed loop transfer function, okay, of a negative unity feedback system. So how to find GS? GS is your OLTF, very simple. So CLTF, we have just now seen the relation. It is what? OLTF divided by 1 plus OLTF. So simply write this 10 divided by S square plus 10S plus 20. So OLTF, let me write it as GS divided by 1 plus GS. Now look what I do. So if I subtract the numerator from the denominator, so this will be what? 10 divided by S square plus 10S plus 20 minus 10 is equal to GS divided by 1 plus GS minus GS. So GS gets cancelled. So over here we get GS is equal to 10 divided by S square plus 10S plus 20. Sorry, plus 10. So this is the open loop transfer function of this system. Okay. So very easily we can find for a negative unity feedback the open loop transfer function. But for a closed loop we cannot, for a non-unity feedback this relation does not hold true. Okay. This relationship does not hold true because then we have HS over here. Okay. HS over here. So we cannot employ this relationship. Tell me if this is clear. If you have any doubts, then please let me know. Any doubts? Mangesh, Surjit?
No, sir.
Okay. So Surjit, have you given gate this year?
Yes, sir. I have appeared actually.
Okay, so wait then.
Okay.
Because today we have like only a small class 1 hour session. Okay. So now let us see what is transfer function. So can you tell me basically what is transfer function, Surjit? See, I will only say it's okay. Means if you say, then it will take time. So transfer function, everyone says, means in all the book, Laplace of output divided by Laplace of input when all the initial values are 0. Okay, all the initial values 0. So actually from where does this come? Okay, where does this definition come from? So basically any system, see, any system like this GS, any system, it is modeled. Okay, it is modeled using a set of differential equations. It is modeled using a set of differential equation. Now that differential equation, it might look like this. Okay, it might look like this. So now we know what if x of t, so these are all in time domain. I haven't written t in parentheses in all the places. Okay, I haven't done that. So if xt has Laplace transform x of s, then we know what d by dt xt has Laplace transform s xs minus x of 0. Similarly, if it is d square by dt square, so over here we have Laplace transform s square xs minus s x of 0 minus x dash 0. Okay, we will have Laplace transform like this. So these all values x of 0, x dash 0, these are all initial values. And you should know, if you have studied signal system, that your initial value or a constant value, it basically introduces non-linearity. Non-linearity. So like this equation, y is equal to mx plus c. Now you might feel that this is linear, but if this is a linear characteristics always is a straight line passing through the origin. Okay, if over here this expression we have, so this will look something like this. This is not a linear equation. So for this to be linear, c needs to become 0. So if c becomes 0, this will be y is equal to mx. So this c is actually what? It is your constant value, and over here this constant values are basically initial values. So when I do initial value as 0, so your Laplace transform for the differential coefficient, it becomes like this. So I can rewrite it something like this. So if I write ys by xs, so then this becomes what? Bm s to the power m plus b naught divided by am s to the power n plus a naught. So this is actually what? This is actually your definition of Laplace transform. Here you can see what I have done. I have taken the Laplace transform of output, Laplace transform of input. Okay, then what I have written means I have separated it in your terms of ys and xs. So this is the Laplace transform of output, and I have separated this differential, it means I have converted this differential equation into an polynomial expression in the order of s to the power n and s to the power m, or in terms of polynomial of your variable s, where s is what? It is your s, means it is your complex variable. So this is the perfect definition of transfer function. That transfer function are basically what? It is the polynomial function of your input differential equation and output differential equation. And over here we have basically what? We have initial value 0 to maintain this linearity, or else transfer function cannot be written for a non-linear system. Okay, it cannot be written for a non-linear system. So that is why over here we have what? We have this initial value 0 to maintain your linearity of the system. So this is what is your transfer function. Okay, so next is what? Poles and zeros. So that is very simple. So this is what? This was your transfer function. So poles are basically what? Poles are basically when you equate the coefficients of your output to 0, to get the roots of this polynomial equation, that is known as your what? That is known as your poles. So poles are all those values of S, okay? All those values of S all the values of S for which magnitude of transfer function is equal to infinite, or basically roots of polynomial of your output, or in your transfer function, in transfer function, roots of denominator is what? It is your poles. And what are your zeros? Zeros are basically roots of polynomial of your input differentials. When it is equated to 0, we get what? We get zeros. Or simply, if you want to say, for the transfer function, roots of numerator. Roots of numerators are what? It is 0. And if you want to define it, basically all the values of S for which magnitude of transfer function is 0. So these are the definitions of poles and zeros. Sometimes it might be asked, based on the position or location of this pole, we can define a lot of quantities in your classical control system, and even in your other control systems also, like your nonlinear control system. Poles play a very important part. Even in your, means if you want to represent a system using state transition matrix, means STM, state space model also, even in state space model we have what? We have your poles and zeros. So poles and zeros are every place. Even in your advanced control system, every place, if you study control system, you will always have poles and zeros. Even in non-linear control system, distributed control system, every place you will have poles and zeros of a system. So it plays very important role in your system. Okay, so the definition, complete definition of poles and zeros I have written over here. Okay, so the next topic is what? Type and order of transfer function. Okay, type and order of transfer function. So remember this, type. Type is basically the number of poles of a transfer function at origin, or you can write number of poles at s equal to 0. Okay, so this is the definition of type. Now we should know how your S-plane looks like. So this is your S-plane, this is your sigma, real part, and this is j omega, imaginary part of S-plane. Okay, so whatever poles lies at this position, that is known as type. And one more thing, important point, type is only defined for OLTF. Type is only defined for OLTF. Even if they ask you what is the type of the closed loop system, you should say the type of OLTF for the corresponding CLTF. Okay, so type is only defined for OLTF, type is not defined for CLTF. Next is what? Next we have is order. So what do we mean by order? Order is what? Order is your total number of poles in a transfer function, or basically what you can write, highest power of s in denominator of transfer function. And your order, it is defined for both OLTF as well as CLTF. Okay, it is defined for both OLTF and CLTF. Always remember, type is only defined for your OLTF only. Any doubts up to this point? Surjit, Mangesh, any doubt? Anyone?
No, sir. Clear.
So today we will do what? So today we had the session till 7:30 only. So in tomorrow's session, we will continue this session. Sri Hari will see. So in tomorrow's session, we will start from 5 to 8 p.m. Okay. So that will go from 5 to 8 p.m. Okay.